Yes, it is standard practice in many electrical installations to bring the line-side power to the hinged side of the fuse block. This practice has several advantages. Firstly, safety. When the fuse block is open, meaning disconnected, the line-side power is isolated from the load side. This prevents accidental contact with live terminals and reduces the risk of electrical shocks. Secondly, maintenance. The hinged side of the fuse block is typically easier to access, allowing for quicker and more convenient fuse replacement or maintenance. Thirdly, consistency. Bringing the line-side power to the hinged side ensures consistency in wiring practices across different fuse block installations. And fourthly, code compliance. In some jurisdictions, electrical codes may require the line-side power to be connected to the hinged side of the fuse block. By following this standard practice, electrical installers can enhance safety, improve maintenance efficiency, and ensure compliance with relevant codes. When dealing with electrical installations, adherence to established standards and best practices is crucial for ensuring safety and operational reliability. The practice of bringing the line-side power to the hinged side of a fuse block is a prime example of such a standard, and its importance cannot be overstated. Let's delve deeper into the rationale behind this practice and its implications. The primary reason for bringing the line-side power to the hinged side of the fuse block is safety. When the fuse block is in the open or disconnected position, it means that the circuit is intentionally interrupted, usually for maintenance, inspection, or troubleshooting. By ensuring that the line side, which carries the incoming power, is isolated when the fuse block is open, the risk of accidental contact with live terminals is significantly reduced. This isolation prevents electrical shocks, which can be hazardous or even fatal. Imagine a scenario where the line-side power is connected to the fixed side of the fuse block. In this case, even when the fuse block is open, the terminals on the fixed side would remain energized. If a worker inadvertently touches these live terminals while performing maintenance, they would be exposed to a dangerous electrical shock. By contrast, when the line-side power is connected to the hinged side, opening the fuse block effectively disconnects the incoming power, rendering the terminals on the fixed side safe to touch. This simple yet effective design feature greatly enhances the safety of electrical work. Another significant advantage of this practice is that it improves maintenance efficiency. The hinged side of the fuse block is typically designed to provide easy access to the fuse itself. This allows for quick and convenient fuse replacement or inspection. When the line-side power is connected to the hinged side, the fuse can be replaced or inspected without the need to energize the entire circuit. This saves time and reduces the disruption to other parts of the electrical system. Furthermore, the hinged design of the fuse block often incorporates a mechanism that automatically disconnects the power when the block is opened. This adds an extra layer of safety by ensuring that the circuit is de-energized before any maintenance work begins. The consistency in wiring practices is another important benefit of bringing the line-side power to the hinged side of the fuse block. By adhering to this standard, electrical installers can ensure that fuse blocks are wired in a consistent manner across different installations. This consistency makes it easier to troubleshoot and maintain electrical systems, as technicians can rely on a predictable wiring configuration. In addition, consistent wiring practices reduce the risk of errors during installation and maintenance. When everyone follows the same standard, there is less chance of miswiring or misinterpreting the circuit layout. This ultimately leads to safer and more reliable electrical systems. In many jurisdictions, electrical codes require the line-side power to be connected to the hinged side of the fuse block. These codes are designed to ensure the safety of electrical installations and to protect workers and the public from electrical hazards. Compliance with these codes is not only a legal requirement, but also a moral obligation. By following the standard practice of bringing the line-side power to the hinged side of the fuse block, electrical installers can ensure that their work meets the requirements of the relevant electrical codes. This helps to avoid costly rework and ensures that the electrical system is safe and compliant. The electrical codes are constantly evolving to reflect the latest advances in technology and safety practices. It is important for electrical installers to stay up to date with the latest code requirements and to incorporate them into their work. Failure to comply with electrical codes can result in fines, penalties, and even legal action. The NEC, or National Electrical Code, is a widely adopted standard for electrical installations in the United States. It provides comprehensive guidelines for safe and reliable electrical systems. While the NEC may not explicitly mandate the connection of the line's side power to the hinged side of the fuse block in every situation, it strongly implies this practice through its general requirements for safety and accessibility. For example, the NEC requires that electrical equipment be installed in a manner that allows for safe and easy maintenance. Connecting the line's side power to the hinged side of the fuse block helps to achieve this goal by providing a convenient and safe way to disconnect the power for fuse replacement or inspection. Additionally, the NEC requires that electrical equipment be protected from accidental contact with live parts. The hinged design of the fuse block, when used in conjunction with proper wiring practices, helps to meet this requirement by isolating the line's side power when the block is open. Furthermore, the NEC contains specific requirements for the labeling of electrical equipment. Fuse blocks should be clearly labeled to indicate the voltage, current rating, and other relevant information. This helps to ensure that the correct fuses are used and that the equipment is operated safely. In addition to the NEC, many local jurisdictions have their own electrical codes that may be more stringent or specific than the NEC. It is important for electrical installers to be familiar with the local codes in their area and to comply with them accordingly. Local codes may address specific issues or concerns that are not covered in the NEC. For example, some local codes may require the use of specific types of fuses or fuse blocks in certain applications. Others may have additional requirements for the grounding and bonding of electrical equipment. To summarize, the practice of bringing the line's side power to the hinged side of the fuse block is a widely accepted standard that enhances safety, improves maintenance efficiency, ensures wiring consistency, and promotes compliance with the electrical codes. By following this standard, electrical installers can create safer, more reliable, and more maintainable electrical systems. Electrical systems are composed of numerous components working together to provide power safely and efficiently. Understanding the function of each component and adhering to best practices during installation and maintenance are essential for ensuring the overall reliability and safety of the system. The fuse block, though seemingly simple, plays a critical role in protecting electrical circuits from overcurrents, and the way it is wired significantly impacts its effectiveness and safety. Let's explore some additional considerations related to this standard practice. One important aspect to consider is the proper selection of fuses for the fuse block. Fuses are designed to protect electrical circuits from damage caused by excessive current flow. When the current exceeds the fuse's rated capacity, the fuse element melts, interrupting the circuit and preventing further damage. It is crucial to select fuses with the correct voltage and current ratings for the specific application. Using fuses with ratings that are too high can defeat the purpose of the fuse block, as the circuit may be damaged before the fuse blows. Conversely, using fuses with ratings that are too low can cause nuisance tripping, which can interrupt power unnecessarily. The NEC provides detailed guidance on the selection of fuses for various applications. It is important to consult the NEC and to follow the manufacturer's recommendations when selecting fuses. Another important consideration is the proper grounding and bonding of the fuse block and associated equipment. Grounding and bonding are essential for preventing electrical shocks and for ensuring the proper operation of protective devices. Grounding provides a lower resistance path for fault current to flow back to the source, which helps to trip circuit breakers or blow fuses quickly in the event of a fault. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage potential and to prevent dangerous voltage differences from developing. The NEC contains specific requirements for grounding and bonding electrical equipment. It is important to follow these requirements carefully to ensure the safety and reliability of the electrical system. In addition to the technical aspects of wiring and grounding, it is also important to consider the physical environment in which the fuse block is installed. Fuse blocks should be installed in a location that is accessible for maintenance and inspection. They should also be protected from physical damage and from exposure to moisture and other contaminants. If the fuse block is installed in a harsh environment, it may be necessary to use an NEMA-rated enclosure to protect it from the elements. NEMA enclosures are available in various ratings to provide different levels of protection against dust, water, and other environmental factors. Proper labeling of the fuse block and associated circuits is also essential for safety and maintenance. The fuse block should be clearly labeled to indicate the voltage, current rating, and the circuits that it protects. This helps to ensure that the correct fuses are used and that the circuits are properly identified during maintenance and troubleshooting. In addition to the fuse block itself, it is also important to consider the wiring practices used to connect the fuse block to the electrical system. The wiring should be of the correct size and type for the application, and it should be installed in a neat and workmanlike manner. Loose or damaged wiring can create a fire hazard and can also cause electrical malfunctions. The NEC provides detailed guidance on wiring practices for electrical systems. It is important to follow these guidelines carefully to ensure the safety and reliability of the system. Regular inspection and maintenance of the fuse block and associated equipment are also essential for ensuring the continued safe and reliable operation of the electrical system. Fuse blocks should be inspected periodically for signs of damage, corrosion, or overheating. Fuses should be replaced if they are blown or if they show signs of deterioration. Wiring connections should be checked for tightness and corrosion. Any problems that are found should be corrected promptly. In conclusion, the practice of bringing the line side power to the hinged side of the fuse block is a widely accepted standard that enhances safety, improves maintenance efficiency, ensures wiring consistency, and promotes compliance with electrical codes. By following this standard and by paying attention to other important considerations such as fuse selection, grounding and bonding, environmental protection, labeling, and wiring practices, electrical installers can create safer, more reliable, and more maintainable electrical systems. Remember that electrical work can be dangerous if not performed properly. Always consult with a qualified electrician if you have any questions or concerns about electrical installations. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always follow all applicable codes and regulations when working with electrical systems. By adhering to these principles, you can help to ensure the safety of yourself and others. When examining the specifics of fuse block construction, it's important to note that various types exist, each designed for particular applications and voltage levels. Cartridge fuse blocks, for example, are commonly used in higher voltage circuits and often feature a more robust construction to handle the increased electrical stress. Lathe-style fuse blocks, on the other hand, are frequently found in lower voltage applications such as automotive or appliance circuits. Regardless of the type, the fundamental principle of bringing the line side power to the hinged side remains crucial for safety and ease of maintenance. Furthermore, the materials used in fuse block construction play a significant role in their performance and longevity. High-quality fuse blocks are typically made from durable, heat-resistant materials such as phenolic or thermoplastic compounds. These materials provide excellent electrical insulation and can withstand the high temperatures that may occur during fault conditions. The contacts within the fuse block are usually made from copper or brass, which offer good electrical conductivity and corrosion resistance. In addition to the physical construction of the fuse block, the method of mounting and securing it is also important. Fuse blocks should be securely mounted to a stable surface to prevent vibration or movement, which could damage the connections or cause the fuses to become dislodged. Proper mounting also ensures that the fuse block is easily accessible for maintenance and inspection. When installing a fuse block, it is essential to follow the manufacturer's instructions carefully. The instructions will provide specific guidance on wiring, mounting, and fuse selection. Failure to follow the manufacturer's instructions could result in improper installation, which could compromise the safety and performance of the electrical system. Moreover, it is critical to use appropriate tools and techniques when working with electrical equipment. Using the wrong tools or improper techniques can damage the equipment or create a safety hazard. Always use insulated tools when working on energized circuits, and be sure to disconnect the power before performing any maintenance or repairs. Another important consideration is the environmental conditions in which the fuse block will be operating. If the fuse block is exposed to moisture, dust, or other contaminants, it may be necessary to use a NEMA-rated enclosure to protect it. NEMA enclosures are available in various ratings to provide different levels of protection against environmental factors. The selection of the appropriate NEMA rating will depend on the specific environmental conditions. In addition to protecting the fuse block from environmental factors, it is also important to protect it from physical damage. Fuse blocks should be installed in a location where they are not likely to be struck by moving objects or subjected to excessive stress. If the fuse block is installed in a high-traffic area, it may be necessary to install a barrier to protect it from accidental damage. Proper documentation of the electrical system is also essential for maintenance and troubleshooting. The electrical system should be documented with accurate wiring diagrams, fuse schedules, and equipment lists. This documentation will help to ensure that the system can be easily maintained and repaired. The wiring diagram should show the location of all fuse blocks, the size and type of fuses used, and the circuits that they protect. The fuse schedule should list the fuse number, the circuit description, and the fuse rating. The equipment list should include the manufacturer, model number, and serial number of all major electrical components. Finally, it is important to remember that electrical safety is everyone's responsibility. Always be aware of the potential hazards of electricity and take precautions to protect yourself and others. If you are not qualified to perform electrical work, always hire a licensed electrician. Electrical work can be dangerous if not performed properly, and it is always better to err on the side of caution. By following these guidelines and by adhering to established standards and best practices, you can help to ensure the safety and reliability of electrical systems.